Hello, my dear student. This is spring semester. I welcome you in this semester and in my course. My course is a digital electronics tool lab. So this is week one. In this week, we'll introduce about how to do the lab report and the experiment, and how to do the simulation part, and we will done a small simulation in today. At first, you see, when you enter my course, you will see the syllabus and the recommended textbook and a simulation software. In the simulation software part, you see, please download and install the simulation software before start the lab class. Please see the video tutorial before installing the software. Please see the video tutorial. In the software, you will see a help file how to install. Because we use crack version, if you don't follow the help instruction, the software will not be cracked, then you will face problem to use this software. So before installation, you see the file, and you can install as per instruction. Okay, this is week one. In this week, we'll do an experiment. What is study of operation amplifier as a comparator and amplifier. Here, so many parts in the left. What you see, study of operation amplifier as a comparator and amplifier. So here, part experiment 1, zero crossing detector, and experiment 1B, part B, 1A, positive and negative voltage level detector, and part C, inverting amplifier and non-inverting amplifier performance. So this is our starting class, introduction class. That's why we only done the first one, part 1A. You see here, I already upload. Here I already upload a lab report, and in PDF format and PPT format. And this is forum. You have to participate in the forum. I give a question. You have to answer the question. You have to answer this question, and you will find a weekly forum mark. And then assignment. In the assignment folder, you have to give the simulation save project file. You have to give the simulation file here. And this is lab report. In the lab report, in the lab report folder, this one is the same. In the lab report, you have to give the cover page, experiment norm, experiment name, and theory, circuit diagram, simulation diagram. Take a screenshot from simulation software, data table or waveform. Everything you have to write on your own hand. No computer type and other format is acceptable. So you have to write it down on your own hand. Only you can take the simulation diagram and the waveform from the simulation software by taking the screenshot. And assignment folder, please submit the simulation project save file here within due time. Here only you can submit the simulation project save file. I'll show you which file. And forum have a question. You have to answer this question. The forum part. I already asked the question. You have to answer, and I will give the mark accordingly. So hope you understand. You have to participate in the forum. You have to give the project file here and lab file here. Lab file format is this: the cover page, experiment name, theory, circuit diagram, simulation diagram, data table, waveform, etc. So go to the lab report. You see, yep. This is experiment name and nom and experiment name. Here is a theory. Some small theory is added here. You see, this is an open. We study the study of operation amplifier. This is operation amplifier short form is open. You will learn this open. You will learn this open in your theory class also. And open is an integrated circuit. You see, and like this one, it has a 8 terminal. We use 741 IC open. This is a 741 IC open pin configuration, 8 terminal. It has first one offset null, then inverting input, non-inverting input, plus V, NC means no connection, minus V, this is plus B, 7 terminal output, offset null. Offset null we use for critical issue, so don't think, don't now it is not needed to think about offset null. Inverting, non-inverting, and minus B, plus B, and output. This is a biasing voltage plus B minus B. If we give the voltage plus B here and minus B here, then this device will be active. And this is input terminal, inverting input terminal and non-inverting input terminal. These two are input terminal, and output terminal is so. You see, these two are input terminal. This is output terminal. This is here others are used, but here is the this is the circuit symbol diagram. That's why it is simplified. Come to zero crossing detector. This is zero crossing detector. This is one is non-inverting zero crossing circuit, and this is inverting zero crossing circuit. What is zero crossing circuit? What is the function? If we do the experiment, then it will clear to us. So now we will go to the simulation part and see the zero crossing circuit diagram and its input and its output, and then we will understand what is zero crossing. Zero crossing detector is when an AC signal crossing the zero level, then it will also change the it will also change the output voltage level. So for the first experiment, you have to give this experiment name, nom name, and this QD, and the circuit diagram, then simulation diagram, and the waveform. Go to the Proteus software. This is the Proteus software. After installation, you will find this logo in your desktop. First open, it will look like this. You just click new project. Give a project name. এখানে রেকর্ড করতেছি। Sorry, you have to give a project name. Give zero crossing The crossing detector. You, you see the path. See user minor documents. I need this file for assignment. You will find this file here. User minor documents. Next, get a symmetric from the selected template. Next, next, and finish. Then it will open this template. Now we have to draw this circuit here. We need this open 741. How can we find? You see there is a P. Just click on P. Keyword. Write 741. Open. Just click OK. We need this source sign. V sign. Register. Just write RES and it will come the register. So take the open and register just here. You see the register is parallel, horizontal, vertical. So you have to rotate this register clockwise. Just connect V sign. You have to give V sign in the positive terminal. To give the V sign in the positive terminal. So here just connect. Oh, you need another. You see apply plus 12 volt minus 12 volt biasing voltage in pin 7 and pin 4. We need battery. Right cell and you will find cell. Click cell. Just here is positive, so this is anti-clockwise. This one is positive terminal, this one is negative. So positive terminal should be connected with 7 volt and there negative terminal will be connected with 4 volt. So rotate 180 degree. You see the diagram. So we need ground. We need the ground. Connect this on ground to connect with this one with ground. Connect all the element with ground. This terminal connect with ground. You see minus terminal connected with ground. So we provide 12 volt minus 12 volt pin 7. We need to provide this should be 12 volt. This should be also 12 volt. And this register 1k and whatever you can change 10. You can take 10k, 1k. Just edit properties. 1k. No problem. And you have to give 5 volt peak and frequency 1 kilohertz. 1 kilohertz is very large. Design amplitude you give 5, frequency you take 10. It is better to observe the give, but it is better to observe the website. Just keep 10. And this is the complete circuit. And we need to see the input and output. What is the variation? Just take the probe mode. This is probe 1. This is input terminal. This is output terminal. From where we should graph, you see there is a graph mode. Here graph mode. Just drag and drop. You see this one. Extend like this way. Just right click, add trace. First you take V1 plus, this is input. Then again add trace. Then take R1. Just run. You need to run this circuit from here. Just run. You see, circuit is working. And then stop. Oh, sorry, some problem showing. Need to see the problem. Now it's working. You see the graph. V1 is the input. So V1 is in green. You see the green one is input. R1 is red. So R1 is the output. You see a sine wave. Input is a sine wave. In a sine wave, when it crosses the zero level, this one is zero level, then it will also change. Output also change and give a square wave shape. Okay, this is called non-inverting. Why it is called non-inverting? You see, when the sine wave is positive, the square wave is positive. When the sine wave is negative, square wave is negative. So when sine wave is positive, square wave positive, and when sine wave is negative, square wave negative. That's why it is called non-inverting. It will not change the direction in the output. That's why it is called non-inverting. And for inverting, just you see change this terminal. Just change. So you need this circuit diagram in the lab report and this diagram in the lab. And now for another one, the inverting. For inverting, just we need to remove this one. Just from here you find your equipment V sign. You have to add the source voltage the button. And now this terminal will be grounded. Again you have to give this one is 5, frequency is 10. and take a probe here. Just run. After run, stop, close this and enter a space. Oh, it is only shown the input, output. Just take a new graph, add trace here, v1, add trace again, r1, run, stop, and you see now when sine wave is positive, square wave is negative. So the opposite value, and when sine one is negative, square value is positive. So inverting the value, input or direction is inverting in the output terminal. That's why it is called inverting. Hopefully you understand the difference between two circuit diagram. This two circuit diagram, you have to give this diagram and the web shape in the lab report also. And zero crossing detector function is when it is cross the zero input terminal. When the sine wave is crossing the zero level, also indicate this part is crossing zero level. This part is crossing zero level. This sine wave is crossing zero level. It will indicate input sine wave is crossing the zero level. In your theory course, you will learn these topics briefly. Today, we are now finishing this simulation part. You have to save and you have to go user inner you have to sorry, I forget the link where the file is saved. Just again and to see user minor documents. User documents. Here you will find the project shape file zero crossing detector. I need this file, Proteus file. You see this file. I need this file, zero crossing detector Proteus file for assignment folder. Only this file, nothing else. Only this file. You have to submit in the assignment folder. This is our first class. So many problem will be arise. If any problem, you can just call me within the office hour. And it is better if you share with your share all the problem. Here will note all student problem. They can discuss on. It is very easiest way. But if your share will not uh, so much active, then you can call me directly. No problem. For that, for today, thank you. Hopefully next week we'll meet you again. Thanks.